All right, my friends, let's continue with this. This is a richer, longer problem, but still very doable using the calculus that we know, and it'll also give us an opportunity to practice the number line test and some other really important skills. So, we have a particle initially located at x of 0 equals 3, so its initial position is 3 whatever, moves along the x-axis in such a way that its position at time t, measured in seconds, is given by a continuous function. We love our continuous functions. X of t equals 3t to the fourth minus 16t cubed plus 24t squared on the interval 0 to 5. The position of the particle x of t is going to be measured in meters. That's going to be important. Time is being measured in seconds, so our units are going to be some combination of meters and seconds. The first question is going to be at what value is the particle at rest? Next question, at what values of t does the particle change its direction? C, the third one, what is the displacement? The displacement just means change in position of the particle from t equals 2 seconds to t equals 4 seconds. We're going to look at where is the velocity increasing. We're going to use correct units to explain the meaning of v prime of 3 equals 84. We're going to, what's the velocity of the particle when the acceleration is first equal to 0. And then we're going to actually try to graph the position function and the acceleration function. So let's get going. Okay, at what value of t is the particle at rest? If the particle is at rest, what I know is the velocity must be equal to 0. When I'm not moving, my velocity is equal to 0. Well, how do we get the velocity? We're going to take the derivative. We're going to use the shortcut rule. You bring the power down and multiply, and you reduce the power by 1. Bring the power down and multiply, reduce the power by 1. Bring the power down and multiply, reduce the power by 1. I need to know where that equation is equal to 0. So 12t cubed minus 48t squared plus 48t is equal to 0. I see a common factor of 12. I see a common factor of t. When I do that, I get the new polynomial, t squared minus 4t plus 4 is equal to 0. I'm pretty sure I can factor this polynomial. That's going to be t minus 2 times t minus 2. If this is the velocity expression, where is the velocity equal to 0? Well, that's going to happen if 12t equals 0, or t minus 2 equals 0, or t minus 2 equals 0. So I see at t equals 0 seconds, at t equals 2 seconds, and again at t equals 2 seconds. At those, really 3 answers, but really at 2 points, the particle will be at rest. Great. The follow-up question, at what value does the particle change its direction? Well, in order for the particle to change its direction, another way to say that is velocity. V of t has to change from positive to negative, or from negative to positive. This is where our number line test is going to be really helpful. So I'm going to do a number line for the velocity. I know that at time 0, the velocity is equal to 0. At time t equals 2, the velocity is equal to 0. Furthermore, I'm only interested in the velocity of this particle between 0 and 5 seconds. So here's 0, right? Over here, t equals 5 is the end of our interval. All I care about is the velocity of the particle between 0 and 5 seconds. So my number line people are going to select a value of time between 0 and 2. I choose t equals 1. That'll be a nice number. And we're going to go back to our original derivative, and we're going to plug in 1 into any one of these 3 functions. It doesn't matter to me which one. I'm going to use this one because I think it's easier to work with, and evaluate that function at 1. I get 12 times, let me write this over here If t is equal to 1, 12 times 1 is positive 12. 1 minus 2 is negative 1. 1 minus 2 is negative 1. At time t equals 1, I have positive times negative, positive. The velocity is positive. In fact, the reason why I wrote all those positives, the velocity won't be positive just at t equals 1 second, but for any value of t between 0 and 2. Now, what about something between 2 and 5? For example, t equals 3 could be my test value. Let's go back to the factored form and plug in 3. 12 times 3 is positive 36. 3 minus 2, positive 1. 3 minus 2, positive 1 again. Positive times positive times positive is positive. The question being asked was, where does the particle change direction? We interpreted that as the velocity has to change from positive to negative or negative to positive. Where does that happen? Never. So the conclusion should be the particle never changes direction. And then I would say because the velocity is greater than or equal to 0 for all values of t on the interval 0 to 5. Okay. Let's move on. Okay. What's the displacement of the particle from t equals 2 seconds to t equals 4 seconds? Displacement, as we mentioned, is just change in position. So this is actually a pretty easy question if you've had a physics course. What we need is the position of the particle at 2 seconds, the position of the particle at 4 seconds. So to do that, 3 times 2 to the 4th minus 16 times 2 cubed plus 24 times 2 squared. 2 to the 4th is 16 times 3, 48. 2 cubed is 8 times 16 minus 128 plus 2 squared is 4 times 24, 96. 48 minus 128 is negative 80 plus 96 is 16. Please check me on the calculator. X of 4, 3 times 4 to the 4th minus 16 times 4 cubed plus 24 times 4 squared. 4 to the 4th is 256 times 3 is 768 minus 4 cubed is 64 times 16 is 1024. 4 squared is 16 times 24 is 384. And if I do that, I think we're going to get 128. The displacement is found by taking x4, the position of the particle at 4 seconds, and subtracting the position of the particle at 2 seconds. We get 128 minus 16, which is 112, and the units here are meters. Done. Not a very interesting calculus question. I could do better than that. Sorry. All right, next question. On what intervals is the velocity increasing? Well, if velocity is increasing, then what that means is that the derivative of the velocity is positive. What's the derivative of the velocity? Another name for that is acceleration. We had previously shown that my velocity is 12t cubed minus 48t squared plus 48t. If I take the derivative, we're going to use the shortcut. We bring the power down, multiply, reduce the power by 1. That'll give me 36t squared minus, bring the power down and multiply, reduce the power by 1. Bring the power down and multiply, reduce the power by 1. 36t squared minus 96t plus 48. All right, When I look at this, again, I see a common factor of 12. We get 3t squared minus 8t plus 4. I want to know where that is greater than 0. Well, let's see. Maybe this thing in here can be factored. I'm going to factor the old school way. In order to get 3t squared, I need 3t and 3t. Now I look for factors of 4. I know the result has to be negative. So I'm going to try two negatives. Let's see if it's negative 2 and negative 2. 3t times 3. 3t times t, 3t squared. 3t times negative 2, negative 6t. Negative 2 times t is negative 2t for a total of negative 8t. Negative 2 times negative 2 is positive 4. Perfect. What I want to do is I want to do my number line test. In order to do that, I need to find the roots. I know if t is equal to 2/3 or if t is equal to 2, my velocity will be 0. So t equals 2/3, t equals 2. This is my velocity. No, that's the derivative of my velocity. Equal to 0 here, equal to 0 here. I pick a test point like t equals 3. And I'm going to plug it in. 12 is positive. 3 times 3 minus 2 is positive. 3 minus 2 is positive. I get positive answers. Pick a value between 2/3 and 2, like 1. Plug it into your derivative. Positive. 3 times 1 minus 2, positive. 1 minus 2 is negative. Positive times negative is negative. Pick a value before 2/3, like 1/3, and or 0 if you'd like, that's fine. And you're going to get 12, negative, negative, positive. I should have made it clearer on my number line. We're still only looking for values of t between 0 and 5. The initial question was, when is the velocity increasing? Velocity increasing means that the derivative is going to be positive, and I could say that velocity, I'm sorry, that's supposed to say velocity, is increasing. Where is it increasing? It's increasing on the interval 0 to 2/3. At 2/3, the velocity is equal to 0. The velocity is then decreasing, and then the velocity is increasing. So then from 2 to 5. That would be your final answer for that part.